8.1. We're going to talk about states of matter. You can read through these, our goals for this unit. Hopefully you know at least the first three, the states of matter being solid, liquid, and gas, but there's also one we'll talk a little bit about, won't have a lot on the quiz, called plasma. This picture isn't important yet, but notice the arrangement of particles because that's going to be a big deal. And notice that as you add heat, you can move from one state of matter to the next. And we'll talk a lot about that as well. So what determines whether you're solid, liquid, gas, or plasma? Well, it's based upon the particle arrangement. So if you look here in solids, the particles are super close together, as close as they can be. One thing we'll learn soon is they're still moving. They vibrate basically in place back and forth. Particles are always moving no matter what state of matter they're in, but the solid particles are packed closest. If enough energy is supplied where they can move a little freely and slide a little past each other, we become a liquid. Notice in gas, they're more spread apart, so they have more energy. And eventually, you notice these negatives, these electrons are free to roam. There's so much energy, electrons are freed up, and that's plasma, which we'll explain a little more. It's probably the one you're least familiar with. All right, kinetic molecular theory, KMT. A little bit I hinted at in the pictures on the page before. All matter is made of atoms and molecules, and they act like tiny particles. Those little particles are always in motion. They're moving, even in solids where it might not seem like that, but they definitely are. The higher the temperature, the faster the particles move. At the same temperature, so if we're not changing temperature, more massive or heavier particles are going to move slower than less massive or the lighter particles, which is kind of common sense. But the keys here is everything's made of little particles that are constantly moving. The higher the temperature, the faster they move. A little bit more on that. In a solid, we said they move, they just don't move much because they're in a little fixed position. In a liquid, they are packed close together still, not as close to the solid. They have more energy than a solid, but they're able to slide past each other. And in gas, they're in a constant state of motion, they're moving fastest, and they rarely ever stick together. How do we know all this? What observations do we have? We have diffusion in gases and liquids. I'll give you a disgusting example of diffusion. If you're sitting in a classroom and the person next to you farts, you're going to be the first one to smell it because the gas will spread from where there's a lot, right by the person who did it, to where there's not so much. Other people in the classroom will smell it too as it spreads further and further to those low areas of concentration. Brownian movement is another observable example how particles move when they collide. Think of if you pour food dye one drop at a time into water. It's random. You can't predict how it's going to spread out, but it is moving. Go ahead and pause while you put all this in your notes. So going into a little more of each of the states of matter. In solids, we already said the first. Particles or solids are tightly packed like this picture over here. They are moving, they're vibrating, but they are in a fixed position. The new information that you definitely will need on your test eventually is solids have a definite shape and a definite volume, meaning they take up a certain amount of space and they have a certain shape. That's common sense. Look around wherever you are, look around your room, you'll see a bunch of solids that are set in their shape and size, their volume. If you increase the heat, they can become a liquid. In a liquid, the particles are still tightly packed like we said, but they're spread out enough that they can move over each other like you see in that picture. Liquids have an indefinite shape. In other words, they'll take the shape of whatever you put them in. Put them in a glass, they'll take that shape. Pour them on the table, they're spread out. So they don't have a definite shape, so we call it indefinite, but they do have a definite volume. Even if you spread it out, you can measure it would be the same amount as if it were in a cup. Increase the heat on a liquid, and you can get to a gas. Notice the picture shows those particles are moving fast, free, and they're very far apart. And gases have an indefinite shape and an indefinite volume. So gases will spread out as much space as they're given, so they don't have a given or definite volume. So again, solids, definite shape, definite volume. We move to the liquids, indefinite shape, definite volume, and then the last combination we said is indefinite for both. If we add heat to a gas, we get to a plasma. Again, not as much on the test on the plasma. but it's really an ionized gas. So it's a gas that's heated enough where the electrons are kind of freed. That's what the ion is. Plasma is a really good conductor of electricity, and it can be affected by magnetic fields as well. And just like gas, it's also indefinite shape and indefinite volume. Believe it or not, plasma is the most common state of matter in the universe. It's because you'll see later stars like the sun are made of tons of plasma, so that's why it's the most common in the universe. Go ahead and pause this, and you'll definitely need to know these well by the time we get to our quiz. So pause and put these in your notes. Again, you're not doing Pear Deck, you're listening to me teach, but kind of pause when you see these and think. It says list the phases of water in order from the phase of the slowest movement to the phase with the fastest. Hopefully you said, well, solid would be ice, so that's going to be the slowest movement. Liquid water would be the second, and steam, which would be the gas version, is the fastest moving. Draw the particles, the molecules of each of a solid, liquid, and a gas. If you can't remember, go back a few slides and look at those pictures, and hopefully, after you press pause, your solid picture is just going to look like a whole bunch of dots as close as you can make them to each other. Liquids will be a little spread out, but a little bit of space, and gas just very spread out, something like that. Well, you can't see the question, so we will skip that. In what phases of matter do substances have a fixed volume? Fixed means definite. It's just another way of saying definite. Hopefully you picked the first two. Over here, solids and liquids. Solids have fixed shapes and volume. Liquids only have a fixed volume, and gases and plasma don't have fixed anything. In which two states of matter can a substance take the shape of its container? Hopefully you picked liquid and gas, which is kind of common sense. You know, you pour liquid into something, it's going to take its shape. If you blow up a balloon, the gas takes that shape of that balloon. If you want to, Google search that if you want to hear the song, but when you're making it up on your own, you kind of skip those to save you some time. We're going to introduce this today, phase changes. If I go a little fast, don't worry. The whole next set of notes that we do in this unit will be slower and only on phase changes. But a phase change means when you're changing from one state of matter to another, solid to a liquid, liquid to gas, gas to liquid. Any of those changes would count as a phase change. So if you look over here, when a solid becomes a liquid, think of ice becoming water, that's melting. How does the heat move in that phase change? Well, the heat goes into the solid, speeds up the movement of the particles until they have enough movement to spread out a little bit, and they become a liquid. If we go a liquid to a solid, so backwards, let's say we start with water, put it in our freezer and make an ice cube, that's freezing. In that case, heat leaves the liquid. Well, if heat leaves, it's getting colder, the particles move slower, and eventually they get stuck in a fixed position, and they are now a solid. When we're looking here at liquid to gas like water to steam when you're boiling water, that's vaporization. Some people say, well, isn't that boiling or evaporation? Same thing. In fact, if you called it any of those, I'd be fine with it. Just make sure you're familiar that they all mean the same thing in case you only see one of those on your quiz. Well, because we're speeding up again, liquid to gas, we're going faster. That means heat is going in. Gas to liquid. Well, you can think of like when rain clouds form. This is how clouds form. Hopefully you've learned the water cycle. It's called condensation, but we're going from faster molecules to slower, so that means heat leaves the gas. And finally, if we go solid straight to gas, we skip liquid, we heat it up so much, well, obviously heat's going in, and we call that sublimation. Vocab we'll practice a lot eventually. Go ahead and pause while you put that into your notes. What happens if you raise your temperature super high levels, between 1,000 degrees and what is that, 1,000,000,000 degrees Celsius. Will everything just turn to gas? No, remember we said there's plasma. So don't forget about that plasma. We can heat a gas enough, and it's going to be a crazy amount we'd have to heat it. 1,000 degrees is not easy to get to. It can turn to plasma. Where do you see plasma, since it's a term not a lot of you have known? Flames have rate of plasma. Not all flames, but flames that reach those temperatures. Lightning's a good example on Earth where you're going to see plasma. The aurora borealis, the northern lights. Alaska, Canada, you can see those nicely. And again, stars like the sun, and this is why the most common state of matter in the universe, not on Earth, but in the universe, is plasma. You can pause and read through this to look for some other ones. Another one you'd see on Earth would be like neon signs. And the way this picture works is the higher you go up, the higher the temperature. And the further to the right, the more packed the particles are. So like stars and fusion and sun. There is something called cold plasma. We're not going to get into it. It might be confusing. Just be aware it exists. Go ahead and put this in your notes. Press pause, and then you are done.